Right. As I explained earlier with the equation, you can see you can take out the rate of change of velocity outside, and actually it is equal to the acceleration equation. So it basically become a, instead of this whole term, I can say the acceleration simple A. So the term become F is equal to K multiplied by MA. So this K term is a constant. To remove this proportional term, you should always multiply any equation from any side. You have to multiply it by a constant, a known constant. However, in this case, I have to take it as 1, right? I have to take it as 1. So it become F is equal to MA, the mostly used term or the equation in the when it comes to the force law lesson, the Newton's second law. So what is the base unit? Kilograms. M is -2, right? And in the first slide, I have shown you the world's strongest fly, that image, right? So the flea's secret is that he can launch himself at a high speed, which means the A value is going to be very high when it comes to the mass, right? Even though the mass is, the equation is F is equal to ma. Equation is F is equal to ma, and I mean compare it to the size of that flea. I mean, it is not a hand. Compare it to the size of the flea. This is somewhat larger, right? This is the object. This has some higher mass, and to move this one, you need higher force actually. But disregarding the mass of the flea, however, the velocity of this flea is higher. So that is what happened. When the velocity for a small time is increased, what happens? When the velocity is increased over a small time, the acceleration is very much high. So it is instantaneously, this flea is going to jump back. Then you can see the mass is like 2 multiplied by 10 minus 3 grams, right? So basically it is like the mass is going to be 0.002 grams, right? In kilograms, it is also, if I compare this one into kilograms, again multiplied by another 1,000, right? So it is going to be 0. So this is going to be in kilograms, the mass, right? So, however, since the acceleration is high, the force is going to be pretty much high, right? And since we learn about the most commonly used equation, now we have to learn how these. You might wonder how we are measuring these forces in real life scenarios. You can use a. There are some scales supported by the springs internally, also known as the Newton's scales, right? They can directly give you the Newton value, and now you should know how to convert a mass of an object in the earth to an, and you should be able to describe it with the newtons. So basically, let's say the weight of the let's say a football. I will just assume the mass of a football is 200 grams, and let's say it's the next one. Let's take a higher value. Uh, uh, Mass of a book, mass of an aluminium block, let's say it is 2 kilograms. So however, these are the masses, right? Now you know the equation F is equal to ma. And as I said earlier, in the Earth's gravity, the Earth's gravity is applying from the center of the gravity to downward, and this gravity or the gravity of acceleration is equal to, in A levels we say it is the gravitational acceleration is, in the A levels we say it is 10 ms minus 2. However, in the university level we say this G value is going to be 9.8 ms minus 2. However, since you are doing the A levels, you don't need to learn about this one, but in the first year of the university you will get this value as 9.881 actually. So considering the gravitational acceleration as 10 ms minus 2, so what is the weight of an football in newtons? So for to get the value with value in the newtons, right, you have to use this equation F is equal to ma. So m is equal to 0.2 kilograms. You have to convert grams into kilograms. You should know the unit conversion very easily. Otherwise, it is going to be an issue. Especially the relationship between the grams and kilograms, centimeters, millimeters, meters. They can be constantly asked, right? And instead of the ma value acceleration, we will use the Earth's gravitational acceleration 10. So you can just multiply it by 10. So it is going to be 10 Newton. Sorry, 2 Newtons. The mass, so the mass of the football is 200 grams. The weight of the football is 2 Newtons. Then what is the weight of the aluminium block? You just have to multiply it by 10, right? So it is 20 Newtons. So you will get used to this one, this calculation. Whatever the thing you have to find out as a weight is actually force, right? So sometimes students are confusing it when we are asking the mass. What is the mass? Unit of the mass? It is in kilograms. What is the unit of the weight? Weight is not kilograms, it is newtons. You have to use this equation. Just multiply it by the 10. Okay. Right. So in this question, let's look at this question. A car of mass of 500 kilograms, okay, traveling along the flat road. The forward force provided between the car tires and the road is 300 newtons. You can see in this figure. To the right hand side, it is 300 newtons from the tires. And the air resistance is 200 newtons. Into the left hand side, calculate the acceleration of the car. I think that's enough, right? Acceleration of the car, which means they are asking to find out the A value, right? Now, the first thing you have to do, you can draw a freehand diagram or a sketch of this figure. It's better to learn how to draw this freehand sketch. So let's write down like this one, like this. So first of all, I will mark the forces actually from the center point or center of gravity of this car to the perfect vertical. I can draw the weight of the car. So the weight of the car is going to be how much now? Weight of the car, is it 500 kilograms? No, it is going to be 5,000 newtons. Can you understand?
Yes, sir.
Yes, it is not 500. Actually, you can see this calculation is also wrong, right? So they just apply It has okay. The M is okay. It's 5,000 Newton, just 500 kilograms. M. However, this is weight. Oh, the weight. Yes. Then I have to take the force. So here it is 200. Here it is 300. What is the resultant value? Resultant is going to be to the right hand side. It is 300 minus 200. The force is going to be 100. The force is going to be, the resultant force is going to be 100. If I write down the resultant force like 100 newtons, then I don't need these other forces, because instead of those two, I can write down this one. It represent by this 100 newton, right?
So 100 Newton will come for the left side, no?
Is it now? No, no. It should be come to the right hand side. No, no, Gupta. You don't have to, when it comes to resultant force, you don't have to balance the two forces, okay? You don't have to balance the two forces. Whatever the force have the higher value, let's say 300 has the higher value. So there's a high possibility the car is going to driven into the left right hand side, okay? However, it is
Oh,
okay. You can see, right?
yeah, yeah,
Okay.
understood.
Then now, once you get up to this point, again, students are always confusing, because the equation is F is equal to ma. Now they always having the problem with what is going to be the F. I even though I have teach this lesson, instead of S, instead of this F value, they are also applying, okay, this is the F value, 5,000 Newton. So what is the rationale behind that? Remember, the force should have a magnitude as well as a specific direction, right? And in the first Newton's law, they say that the, I mean, it is on, not in the first law. In the second law, actually, the direction of the acceleration, which means in which direction the car is moving, we should apply the force, which means now 5,000 is not the way, this force is not the, like, this is not the car is moving, right? It is not moving downward. So it is moving to right hand side. So this is going to be the force. That is why I cannot use 5,000 as a force in here. Actually, this force does not represent a single value. You can see there is a force system actually. Whenever there are one or more than one force, we call that is a force system. So from a force system, you can take a resultant force, and that resultant force is mentioned by this F. Now, F is equal to ma. We know the mass, we know the force, the resultant force. What is the A value? So it is 0.2, m is minus 2. And if we are good at taking out these terms to one side of the equation, that is also a good practice. Right? Remember the units. It is going to be definitely worth learning. Even for your first year of the university, in every year in the university, it is going to be definitely important. Now, it's a very simple question actually. And here are some questions you can try to do, right? I think let's look at the first question. The car mass of 1,000 kilograms, m is equal to 1,000, traveling at a velocity, okay, it accelerates for 15 seconds, reaching a velocity of 24 ms minus 1. Can you try to do this equation? So as you can see, even though we learned the equation as F is equal to ma, in this case we have to apply the equation. You have to convert that equation like this one, right?
So the first one's answer is 0.9.
Well, I actually didn't get the answers for these things. I'm pretty sure they are correct. Uh,
It's the momentum, right? So final momentum minus initial, so final velocity minus initial velocity over time, right?
yes, yes. This is the equation. If you are wondering, if is equal to mv minus u divided by t, just take the first momentum and the last momentum, the change of momentum of the car over. Yes. So okay. So I think first one is m multiplied by the v. First one is 1000 multiplied by the first velocity. It is going to be 10,000, right? And then accelerate for 15. Okay. Second velocity is 24,000. Uh, so it is only for the 15 seconds. Ne? The change in the momentum in the car is what? What is your answer? It should be 14,000, right? 14,000 kilogram ms minus 1. So here we have the uh, m u. Here we have the mv. So change in moment of the car in the 15. Yes. Okay, if they're asking with in the 15-second period, I have to divide it by the 15 seconds as well, right? So which basically take it as a acceleration. So 14,000 divided by 15, which will give the answer for this one. Yes, it gives as acceleration value, minus 2. Second one, the average resultant force acting on the car.
So what's the equation for the first one? F equal mv minus mu over t, right?
Sorry, first one, right?
The first a equation is F equal mv minus mu over t.
So this is the equation. However, we are going to use to, I mean, we are going to find out this side, right? So mu minus mv means what? If you subtract these two, this is the change in moment, right? Change in moment over a time. So this is also the change in moment. So you can see here, change in moment over the time. So I find out the mv value.
So that is the change of moment, right? So
So this is
that's
the
momentum, right? No?
change of moment, and if I divide it by time, the rate of change of moment. So in this question, they are asking, they have given us the specific time period as well, So that is why I have to divide it. Or if it is not a case, then I can just say 14,000 kgms minus 1. Actually, I think the answer should be 14,000, right? So they are not asking the acceleration, for that specific time. Okay. However, with the availability of time, I can just divide it and get it as a just the same change of moment over the time. Second one, the average resultant force acting on the car as it accelerates. And since if you take this one for an answer, you can take out the the acceleration, and if you divide the acceleration by the multiplied by the, again if you multiply this acceleration value by 1000 for the mass of the car, you can take the resultant force, which means basically F is equal to ma, right? Right. In the second question, they have given us the force, right? Then the time is also given, right? And now they're asking what is the change in the ball's momentum. And the direction of the change in the momentum. So I will share this one with you. You can try to do this, you can try to solve these questions. I think I have possibly have the answers as well. I will share it with you guys as well. So until then, we'll discuss the Newton's third law, which is the very easiest law to remember actually. It is stated that when any object interact, for example, you can see that there's a ball in here, there's a table, and here there's an interaction, right? There's an interaction. So these two objects, for example, let's say this ball and the table. So they means the ball and the table exert equal, they exert equal and opposite forces on one another. And the best example, here you can see the weight of the ball. Actually, this freehand, I mean the freehand diagram is wrong. Why I am saying that is wrong? So the weight of the ball is applied from the center of gravity of the ball, which means the midpoint to this direction. And let's say it is 20 newtons. The weight of the ball is 20 newtons. Okay. And the other force is the reaction force. So whenever there is action, there should be a reaction. So reaction for this weight of the ball exert on the table is from the tabletop. Equal force applying over the same line of action through the center of gravity of the ball upward. So this is called as a reaction force. And in this equation, they say Newton's third law, these two, whenever any object is interacted, they exert equal 20 newtons, then the reaction force is also 20 newton. And the opposite forces on one another. These are, you can see, opposite forces. Okay. And best way to, you can see, in some textbooks, when it comes to the higher education, you can call this one as a normal force, right? However, this is not the origin, okay? Normal force, the origin here is it is very wrong. It should be start from the tabletop. Excuse me for a second.
So the reaction force and normal force is the same thing.
Same thing actually, yes, same thing. What I am saying is that the origin of the normal force is wrong. It should start from the tabletop. How, I mean, if it is 100% correct, it should be in the same line of action, right? It should be something like this. And if we draw the freehand diagram like this, the examiner of the exam cannot understand whether we know how to mark the reaction force. So that is why we can split up like with a small distance like this, like separate arrows like that. That is the reason. Um, okay. Right. So here are some free body diagrams. So there's I think the ice hockey, the puck is here. You can see from the point, yeah, I mean, it doesn't matter what is the shape of the object, we can just put the diagram like this. There are two forces in the same thing. Right. It is not always limited to the x and y axes. X and y axes. However, there are some forces applied in the other directions as well, right? Okay, right. And even though we are living in the earth, we are also now undergoing the Newton's third law, right? Because we are interacting with the flow, or we are sitting down in a chair, so that the four legs of the chair is also applying the weight, and they also have the weight, as well as there are four another reaction forces or the normal forces as well, right? So it is explained in here, the contact force of the flow on the foot. Now you have to remember from where to where the force is starting and ending off, okay? So the reaction is from the flow on the foot. The first one is, sorry, the weight of the object, or this weight of this foot is from the foot on the floor, right? And there's also the concept of the upthrust, right? We can talk about the upthrust as well. Whenever where there's a body is immersed, submerged or immersed in the liquid, right? The weight of the boat is also applied as usual, However, depending on this submerged volume, there's another force applying that is not called as a reaction force, okay? That is not called as a reaction force when it comes to the water. It is called as the upthrust. That is the specific term for that. Now, I can ask you a question. Describe one Newton third law pair of forces involved in the following situations, right? Uh, right. Can you think of when you step on someone's toe, right? When you step on someone's toe, from your toe to the other person's toe, there's an action. From other person's toe to your toe, there's another reaction. But what are the conditions to satisfy? The both forces are equal, both forces should be equal and opposite in direction. That's it. equal forces opposite in direction. A car hits a brick wall and comes to rest. The car slows down by applying the brake. You throw a ball upward in the air. Right. So it is the last one is going through. The reaction force is the wind resistance, right? In the last example, the reaction force is the, sorry, oh yes, the wind resistance is going to be the reaction force.
Both one is the answer, right?
Sorry.
Both one is the answer, right? Goes up and comes down.
Yeah, I mean the last example, right? You throw a ball upwards in the air. So action force is going to be your action of throwing the ball.
So the reaction is coming down, right? So
No,
is that
reaction is slowing down up to certain point. So it is constant. At the moment you are throwing ball, it has the highest velocity. But after some time, I just assume that case. I just assume, okay, the ball is throwing upward. Now it has a certain velocity. I assume that one. So, let's now I think you got the same scenario, but you consider, I think, when the ball is hitting the ground, right? So
yeah,
I
it
think,
goes up and comes
yeah,
down, right? So
yeah, but however, in this case, I have to assume that ball is going upward. I mean, after certain time, it is going to stop, and it is again going to come back. Now the action force is going to be the push you are going giving to the ball, and the resistance through the media why the ball is stopping due to the reaction of the air resistance. This is the action and reaction, but in this case also you can say, okay, weight of the ball and the from the ground to the ball, there's an action and reaction. But I think the most suitable consideration is this one, right? However, even though we learn about this Newton's third law, how the people are actually like heavy, I mean, do the heavy lifting works. Like, let's say you have a large pack of, uh, let's say, stationary goods, large pack of them, like huge crates are there. How the person can move them up and down. So in that case, you have to use the momentum. It is also another force subtopic we have to learn. Right. And here are some advanced definitions of the Newton's third law. If one object is exerting a force on a second object, then the second object is also exerting a force back on the first object. These are the conditions. They should have, however, have the same magnitude but act in opposite directions. You can see two people are pushing. I think it's kind of a game called as a tug of war. They should ultimately have the same force in different opposite directions, right?
so sir, we can take tug of war as a Newton's first law example, right?
Yes, I didn't know exactly what is this tug of war means, but I think they are just, I mean, whatever the force they are applying, there should be a reaction force. However, it is not completely correct, right? But because whatever in the end, I think one person is going to win, you know. In that case, that is the third law is not applicable. However, this is only applicable if the two forces are equal to each other, right? Yes. If the forces are only equal by, I mean, the pulling force by the
So
two
the
people are equal,
so con so constant velocity is the answer for Newton's
constant
third law.
velocity. Let's say,
Like that car example, 300 back, 300 front, so 0. So both are giving the
so
same velocity, right?
I think either constant velocity or these two people should be at the rest position, which means the velocity should be either zero, which means they should not move, or they should be in a constant velocity. In both cases are okay. In other than that, that is going to be wrong, because that is not applicable according to the second law, because there's a resultant force, you know. Here also you can see we apply the force. I think I have to end the meeting right now. Let's check.
It will automatically end, sir.
Yes, we'll.
No, it will automatically end. Then you just click on the link and start again.